In part A of this example, we want to multiply a binomial times a trinomial. So we have the cubed root of 3x plus 2, all of that quantity times quantity cubed root of 9x squared minus 2 cubed root of 3x plus 4. Okay, and the way you approach this, we can't use FOIL on it because FOIL only works for a binomial times a binomial. So 2 terms times 2 terms. This one has 3 terms in it. So instead, let's just do a double distribute. Okay, so I'm going to take this first term, distribute it through to all 3 in the second term, and then I'm going to take the 2 here and do the same thing, distribute it to all 3, and then we'll simplify and see what we get. Okay, so first multiplying everything by cubed root of 3x. This gives us, so I'm taking this term through, let's see, cubed root of 3x times cubed root of 9x squared. We're combining inside the radicals since these have the same index of 3. So that gives us cubed root of 27x cubed. All right. Next we multiply cubed root of 3x by negative 2 cubed root of 3x. All right, so we'll combine under the radical there, so we get minus 2 cubed root of 3x times cubed root of 3x is cubed root of 9x squared. Now we'll go cubed root of 3x times 4. Well, that's just simply plus 4 cubed root of 3x. Moving on to the 2 now, we have 2 times cubed root of 9x squared. Well, that's 2 cubed root of 9x squared. Okay, moving on to the next term, 2 times negative 2 cubed root of 3x is minus 4 cubed root of 3x. And then 2 times 4 is 8. And then something wonderful happens here. Looking at our first term here, cubed root of 27 is 3, and cubed root of x cubed is x. So that all simplifies to 3x. Next, look at these two terms, minus 2 cubed root of 9x squared and plus 2 cubed root of 9x squared. Those cancel out. The same thing happens with 4 cubed root of 3x and negative 4 cubed root of 3x. Same thing, but negative, cancel out, which leaves only the 3x and 8. So our final answer here is simply 3x plus 8, which is surprising that such a complicated problem to start with would give us such a nice simple answer. Let's try B. For B we have rad 3x plus 1 plus 2 quantity squared. For that I'm going to use the binomial squared rule. A plus b squared equals a squared plus 2ab plus b squared. Okay, and note this. This is so important, right? It's so easy to leave out the 2ab term, especially when you see it out of context. So a lot of people make the mistake of just taking this 2 through to both terms. That is incorrect. Instead, you want to make sure you include your 2ab term in the middle here. So I'm calling this whole thing a and the 2b. So a is rad 3x plus 1. Okay, using the formula that gives us rad 3x plus 1 squared plus 2 times a, we'll rad 3x plus 1 times b. Okay, b is 2 plus b squared, 2 squared. Okay, so now we can clean this up. Well, when you just have a radical squared, it just undoes it. The radical, so 3x plus 1 there, plus 4 rad 3x plus 1, because 2 times 2 is 4, and then 2 squared is 4, plus 4. Finally, go back and see if we can combine like terms. We can. So let's write this as 3x plus 5 plus 4 rad 3x plus 1. There we go.